Hello, hi everyone. Welcome to the Student the Brand channel. So, in this video, the continuation of the topic will be discussed. That is magnetic effects of electric current. Previous video, I explained about magnets and magnetic properties and baromagnet, magnetic field, and properties of the magnetic field lines. In this video, I'm going to cover solenoid topic, that is, if you take a copper wire, bent, wrap, bent or wrap in the form of cylindrical shape, bent or wrap in the form of cylindrical shape, then you'll get that shape like this. So you can consider like this shape. So you can take the points if you want to get the clear diagram. So you have to consider. So you can take proper or neat diagram. So take the points. So here to here, certain length will be there, certain length will be there, certain distance will be there. So where it looks neat and clear. So two ways we can draw the diagram. Either you can take the circuit near to the rings or away from the rings also we can consider. Then you can draw the circuit here. I'm drawing here for getting better proper neat diagram. So I consider here, right? So I'm considering, so you can see the positive terminal, negative terminal. This is a positive terminal, negative terminal. This is switch. So it's a closer switch, current is passing. So this circular rings acts as a magnet, artificial magnet. That is nothing but a temporary magnet. Here it will act as a temporary magnet. That is nothing but, what is a temporary magnet? So when you remove this battery, automatically it will be demagnetized. It won't act as a magnet until battery connected. It act as the magnet. So that is temporary magnet. So you can take rings. So here until here. So in the middle of the solenoid, the magnetic field will be uniform. So you can consider 5 lines, that's fine, or you can take 6 lines also, fine. 2 lines you can draw up like this, and 2 lines like this you can consider, and 2 lines in middle, and here also you can consider like this, here you can consider, and here also you can take, right? Are you understanding? Are you following my points? So here you can consider, so current is passing through it, and here also. So current is starts moving from positive terminal to negative terminal. So when the current is start moving from the battery, the coil acts as a magnet, the cylindrical shape, that is nothing but solenoid. Solenoid acts as a magnet, that is a temporary magnet. So if you compare a temporary magnet and permanent magnet, so here you can consider, first we will learn it, later we'll learn about the comparison. Then first we can see, when the current is passing through it, the solenoid act as behave as a magnet. Then magnetic field will be created around it. So inside of the solenoid, especially here inside of the solenoid, you can consider in this area. So inside of the solenoid, the magnetic field is uniform throughout the area. So wherever you see all the points, so the magnetic field is uniform at every point. You can observe, you can consider. If you place any magnetic material, so it will get magnetized. So soft iron, if you place, it gets magnetized, it behaves as a magnet. Then magnetic field of the overall solenoid will increase if you place the solenoid, if you place the soft iron inside of the solenoid, nothing but inside of the rings. So if you consider these are the rings, so if you place the soft iron inside, So this soft iron gets magnetized. At the same time, overall the magnetic field will be increased. Why? Already you place the soft iron, so this gets magnetized. This field will be added to the magnetic field of the solenoid. Magnetic field of the solenoid. Right. Understood. Clear. Now, so the direction. So how to find out the direction? So we know if it is there normally bar magnet, we can find out the north pole and south pole of the bar magnet. But whereas solenoid you can see we can't identify the poles. How we can identify the poles? So we can't simply take the here is north pole, here is south pole. We can't consider, right? So we have a standard method, that is clock face rule. So we have a rule, that is clock face rule. Clock face rule. What is the clock face rule? If the current is passing in anti-clockwise direction, that is north pole. The current is passing anti-clockwise direction, that is north pole. So if the current is passing clockwise direction, that is south pole. That is south pole. So this is a clock face rule. Clock face rule. Clock face rule. So if you want notes, I will write the notes and update in the YouTube community, so you can check the photos later. Now listen the class. So here you can see from the positive terminal to negative terminal the current will be passing. So automatically it will be created as a, it will be acted as a, it will act as a magnet, that is temporary magnet, of course. Now according to the clock face rule, we can identify the poles. So according to the wrapping condition also, here if you wrap like this, so if you observe the current will be in anti-clockwise direction. If you wrap opposite to previous winding, then it will be clockwise direction. Depending on wrapping also it depends. So it's fine, but according to the textbook if you follow, here it is south pole, here it is north pole, then you can take here like this, you can consider. So here north pole means magnetic field will be moving out from the point. Okay, so when you are drawing, so in middle exactly all the marks must be in one direction. All the marks must be in one direction. Okay, so you can follow like this. So this is about solenoid. So the top point is solenoid. Clear? Understood? So this is about the solenoid. What are the factors? Depends. So what are the factors influence the magnetic field of the solenoid? What are the factors? First one is strength of the current. Strength of the amount of current is passing through the solenoid. First point. Second point, number of rings. If number of rings are increased, magnetic field also will increases. At the same time, the gap between the rings also we can consider. If, so the gap will be less, so the field will be more. The gap will be more, the field will be, so the strength of the magnetic field will be less compared to previous one. Okay, so this is about the solenoid. So I hope you got the clarity about solenoid topic and how to find out the poles of the solenoid by using clock face rule. So if the current is, again very important this topic, if the current is passing in anti-clockwise direction, that is north pole. If the current is passing in the clockwise direction, that is called south pole. So solenoid is nothing but, so taking the straight wire, copper wire bent in the form of cylindrical shape, then connect to the battery, current will pass, it act as a magnet, that is temporary magnet. So uh, here advantage is whenever we want we can magnetize by connecting the circuit. So by connecting to the circuit, so whenever we don't want we can demagnetize. Whenever we are not using we can demagnetize. So these are very helpful in industries. These are useful. These electromagnets are very useful. Okay, so many applications are there in industrials and even in medicals also. Right. Now comparison of the bar magnet and solenoid. Bar magnet and solenoid. So I am considering here this is a bar magnet, this is a north pole, south pole. So around this one magnet field will be created here. So we'll discuss this point. Okay. So here to here is, here poles are fixed. For the bar magnet poles are fixed, but here poles can be changed. Poles can be interchanged by changing the polarities of the battery. If you interchange the battery automatically, so poles also can change. And one more thing, strength of the bar magnet is fixed. We can't increase the strength. Okay, so it is fixed. If you break down, so it depends, but strength cannot be increased, strength cannot be decreased for the particular given magnet, given bar magnet. Even solenoid, but solenoid you can see we can increase. So already I said factors, so strength of the current and number of loops, air gap, like this we can, based if you change those factors, automatically magnetic field also will change, right? So magnetic field here is fixed, here changed. Poles will be fixed, here can change. Strength can be increased, here strength, here strength can be increased, here cannot be increased, right? So these are the comparisons between bar magnet and solenoid. So hope you like it video. If you want more explanation about any topic, so just comment below. So let me know who are watching this video, to whom it will be helpful, and the same time so it will be helpful to you. So if you have any doubts in a particular concept or in my explanation, and if you get any doubts about any particular point, just comment below. I'll reply to you, I'll try to reach to you. So you can watch my videos. It's about magnetic effects of electric current. This is my second video. Already first video I have done on magnetic field of bar magnet. So this is about solenoid, and one more video also will be there based on current carrying conductor placed in the magnetic field. So hope you like it. Please share, like, and subscribe to my channel to learn about the concepts in creative way, in better way, and innovative way. So in future I'm going to design songs also based on these topics. In future it will come, surely we will work out on it. So soon it will come to you. Thank you so much for watching this video. Yours, student Dibran. Thank you.